It's a quantum leap forward. The first synthetic cell, a new strain of bacteria made by man, and it brings with it many questions. Does it offer solutions to some of the world's biggest problems? Disease, hunger, energy, and pollution? And could it put our lives at risk? Does it change the meaning of life itself? Are we playing God? Those are just some of the questions we'll explore in the next hour. I'll be joined by the man who led this scientific milestone, Dr. J. Craig Venter, as well as other experts. Together, we'll look at what the future might hold. But first, a look at how we got here. After 15 painstaking years, world-renowned scientist Craig Venter and his team have successfully created this, the first colony of living synthetic cells.
This is the first self-replicating species that we've had on the planet whose parent is a computer.
Venter and his team copied DNA from a species of bacteria known as M. mycoides. Using computer code and chemicals you can buy off the shelf, they assembled pieces of DNA, which they put into yeast. The DNA joined together to form the bacteria's genome. It was then transplanted into a different species of bacteria, Mycoplasma capricolum. Amazingly, it booted up, creating a new, living, man-made version of the original bacteria, a breakthrough that may change the way we look at what life really is.
It's a scientific accomplishment. It's a philosophical accomplishment.
The story has sent shockwaves around the world.
It's called a synthetic cell. This single-cell bacterium is powered by man-made DNA that was assembled in a lab.
A stunning scientific achievement that could lead to new cures for diseases, new ways to fuel cars.
Potential benefits, but also wide-ranging concerns about possible risks. How might it affect public health, the environment, and what if the technology falls into the wrong hands? On the same day Venter announced his scientific breakthrough, President Obama asked a special bioethics commission to look at it from every angle, from the ethical issues to the benefits and risks. Does this new life form mark the beginning of a new era of previously unimaginable scientific breakthroughs? Or have Venter and his team opened up a Pandora's box by meddling with nature? As we look ahead, one thing is clear. The future is upon us now.
What do we have?
We have the synthetic cell.
It's alive.
Joining me now is genomics pioneer and biologist Dr. J. Craig Venter, the man who led the team creating the world's first synthetic life. Renowned futurist and inventor Ray Kurzweil, Harvard University molecular geneticist and one of the founders of the Human Genome Project, George Church, and science author and writer at The New Yorker, Michael Spector. Thank you all for being here.
Nice to be with you.
My pleasure. So you are the man that spent some 15 years of your life in the lab working on this, spent more than $40 million. Why is this such a big deal to the rest of us?
Well, it's a conceptual barrier that we've passed, where we've talked about synthetic biology. We've been reading the genetic code for 15 years. We've been putting that code in the computer, and now we've reversed the process. We've started with a computer, made the genetic code now from 4 bottles of chemicals, and activated that in a cell to get a new life form. It means that we not only have a better understanding of the basic processes of life, but it's the first time now we can change all the genetic code in a cell instead of just a handful of genes.
Is it truly a new life? Or are you mimicking life that already existed?
We're definitely mimicking a cell. When you think about starting with this, if we're trying to design something new, 99 out of 100 of our experiments failed. If we're trying to start with something radically new and unknown, they would have all failed. It was tough enough getting it to reproduce something that was known. Now that that's happened, we can now modify the processes and go forward. So this was a proof of concept. This was a baby step, and it was a giant step all at the same time.
How does this change the way we should all look at what life is?
For the first time, you have an organism that is a normal biological organism, self-replicating, whose parent is an email attachment, that is to say, a computer file. that can be modified just like a document on a word processor. And it opens up the opportunity to sit at a computer terminal and design new life forms.
Well, I think the thing that's remarkable about what Craig and his team did is we're moving rapidly into a world where we are coding everything that we do. This is a software. Individuals are going to be software. Everything we create is going to be like a piece of software. And that scares people. It seems cold and distant and unapproachable in many ways. But that is the reality, and it's actually a very exciting reality.
So, George, how would you define life?
Well, I think people get tangled up in this definition of life and trying to make a sharp distinction between life and non-life. I think there will eventually be a blurring between inorganic or electronic life and biological ribosome-based life. There'll be all sorts of intermediates.
Do you see that same kind of blurring of life?
Well, I'm much more down in the weeds of with our team of getting this work done, but the parallel is the codes. So we went from the ones and zeros back to the four-letter code of DNA. But I think, to me, this was the first realization that cells are software-driven biological machines. And I think that's an important change, and certainly how I viewed some life forms.
There's one thing I would note. I mean, a lot of the coverage I've read have commentators that saying, well, it wasn't that complicated a bacterium, and it only went, one small step above what's been done before, and you can't really do practical things with this bacteria. So I actually looked back. It's very similar to what was written after the Wright brothers, that, well, it only was up for a couple of minutes. It only went a few hundred yards. There's only room for one pilot. And that kind of missed the point. This wasn't really intended to be the practical example of synthetic biology, but to show the feasibility of it. Now we can come with much more powerful applications of this new tool.
So just how important is the creation of the first synthetic life? Well, here's what another scientist has to say about that.
The first revolution took place 10,000 years ago when humankind invented agriculture. The second revolution was the Industrial Revolution, in which we built machines, and our technologies have become very powerful and sophisticated. I think this is the third major revolution of human civilization.
Is that an overstatement?
I'm a journalist, and we love overstatements. That's what we do for a living. But I do feel that we get into a sort of terminology problem. Technically, no, it's not an overstatement. I think he's right. But I think what we've been doing with genetic information in agriculture and medicine ever since Watson and Crick figured out how that helix worked was to oversell things, to say this can cure things, this can cause diseases to go away, this will solve hunger. I think all those things are possible. But they're complicated, and it's a process, and it's not magic, and sometimes I think we portray it as if it is.
So, Craig, walk us through what your vision is for how this science will ultimately, you hope, radically change our lives.
Well, what I've argued is we now have 6.8 billion people on the planet, and soon we'll have 9 billion. We have trouble providing food, clean water, medicine, and energy for the 6.8 billion. Without some clear scientific advances, we're going to have a real problem doing that for 9 billion people without destroying our own planet. Biology is one of the approaches that offers possible solutions. And the key word is possible right now. Just like 2 months ago, we didn't have synthetic life. We tried for 15 years to get it. Now we know it's possible. We can now move to the next possibility of trying to engineer cells to better capture carbon dioxide, to convert that CO2 into fuel molecules or into food molecules, new ways to purify water. Probably the first thing people will see, the flu vaccine you get next year could come from our synthetic processes.